What's going on, everybody? Here is your chapter review lesson for chapter 6 on quadrilaterals. The PowerPoint slides are included in on Canvas. There aren't any notes. These are just a bunch of example problems, but the PowerPoint slides are included in Canvas. You can find them there. Okay, so a quick do now review from 6.4 trapezoids and kites. All right, find the two missing angles in both shapes. Well, we see here that this is an isosceles trapezoid, which means that the base pair angles are congruent. This angle is congruent to this. This angle is congruent to this angle, so that means this one is 45. This angle is congruent to this angle, which means that angle K is 135. Okay, that one is pretty easy. In a kite, remember the congruent angles are in between the non-congruent sides. So here are your non-congruent sides, which means that this is the congruent angle. These are the non-congruent sides, which means this is your congruent angle, which means this angle is 110. And now we have 3 of the given angles out of the 4. So we just add them up, 110 plus 110 plus 65 plus this unknown angle X has to add up to give you 360. All right, combine like terms, 110 plus 110 is 220, plus 65 gives you 285, plus X equals 360. Subtract 285 from both sides, and we see that 360 minus 285 gives us 75. So that means this angle here is 75 degrees, right? Now you found all 4. Okay, just a quick review about trapezoids and kites. Okay, so these are the many practice problems that will be similar to what you'll see on the Chapter 6 test. Remember, your Chapter 6 test is on Thursday and Friday this week. Okay, interior and exterior angles of polygons. Remember, this is review from lesson 6.1. Remember, for interior angles, right, you always use the equation of n minus 2 times 180 gives you, so I guess I should change this into an equal sign. The interior angles are equal to n minus 2 times 180, where n is the number of sides. So if a hexagon has 6 sides, we just plug it in, 6 minus 2 times 180 gives us 4 times 180, and 4 times 180 gives us 720. So a hexagon has 720 degrees inside, right? Remember, interior angles. And a 15gon, which and n is 15, n is the number of sides, so then we end up with 15 minus 2 times 180, and which becomes 13 times 180, which is 2,340 degrees in a 15gon. Okay, find the value of X. Well, you remember we need to find out how many degrees are in the shape. We see that it has 1, 2, 3, 4, 5, 6 sides in it, which we just got done saying that a 6-sided shape literally in the question before has 720 degrees, which means that we combine all of these and it has to add up to 720. So we add them all together, 155 plus 98 plus 100 plus 140 plus 120 plus X plus 10. Remember, just because it has X plus 10, it's still representing one angle. And we know that all of those have to add up to give us 720. So go ahead and add all those together. 155 plus 98 plus 100 plus 140 plus 120 plus 10. All of those combined to give you 623. So 623 plus X equals 720. Subtract 623 from both sides, and you find that 720 minus 623, X is equal to 97. So that means X here would equal 97. But remember, X is equal to 97, but the entire angle, which is X plus 10, would be 107. So that angle is 107, X is 97. Remember, there is a difference. Okay, here, remember, now we have exterior angles, and remember, exterior angles, no matter what shape you have, doesn't matter if it's 4-sided, 6-sided, 10-sided, all exterior angles always add up to 360 degrees. So we just combine all 4 of these angles and set them equal to 360. So 72 plus 80 plus 65. Now, again, remember, this is just one angle, so it's plus x minus 7, and all of that has to add up to 360. Now we combine like terms again, so we do 72 plus 80 plus 65. Now minus 7 gives us 210. So we have 210 plus x equals 360. Subtract 210 from both sides, and we find out that x is equal to 150 degrees. Okay. Okay, 6.2 parallelograms. Remember, there's a bunch of things to remember about parallelograms. Find the value of each variable. Well, one of the things that we know in a parallelogram is that opposite sides are congruent. So we set this equation up as 20 is equal to x minus 9. To solve here, we just add 9 to both sides and we get x is 29. Here in a parallelogram, the diagonals bisect each other. So this side is congruent to, or not side, but line is congruent to that line. And then we see that this line is congruent to this line. So that means these two are congruent or equal. So we set that up as 2x equals 16. Divide both sides by 2 and get x is equal to 8. Okay, now in a parallelogram, also opposite angles are congruent to each other. So we set those equal. X plus 23 is equal to 60. All right, subtract 23 from both sides. And we find out that x is equal to 60 minus 23, which gives us 37 there. So x is equal to 37. Okay, rectangle, rhombus, and squares. Obviously, this is not one of those. It just got put into the wrong slide. It's all the same. It's all good. Classify the special quadrilateral, then find the values of x and y, right? So we see that we have 4 right angles. We see that we definitely have very different, this is definitely not a square. So this here would be a rectangle. And then if we're solving for x, these are opposite sides. So we set those equal to each other. 3x plus 2 is equal to x plus 14. Subtract x from both sides, you get 2x plus 2 equals 14. Subtract 2 from both sides, we get 2x is equal to 12. Divide 2 on both sides, you get x is equal to 6. All right, now we see that these are opposite sides from each other, and now those are y, so you set those equal to each other. So we end up with 2y plus 1 is equal to 4y minus 5. Subtract 2y from both sides, that cancels out. We end up with 1 is equal to, remember, 4y minus 2y gives you 2y minus 5. We add 5 to both sides, so we get 6 is equal to 2y. Divide both sides by 2, we get y is equal to 3. If we want to classify this special quadrilateral, we see that we have 2 congruent angles, which means that these are 2 congruent sides. So we know that this, if we're going to identify it, is an isosceles trapezoid. And if these 2 sides are equal and congruent to each other, that means that 17 is equal to x plus 11, which means we subtract 11 and get x is equal to 17 minus 11 gives us 6. So x is equal to 6. This 12 here doesn't really help us much at all. It's just kind of extra information. Okay, classify and then solve. Remember, now we see we have 4 right angles and 4 congruent sides. So this here is a square. All 4 of these are congruent to each other. If we're solving for x's, set the x's equal to each other. If we're solving for y's, set the y's equal to each other, or multiple different ways, right? If we solve for x first, these 2 are congruent to each other, so we can set it up as 3x is equal to 5x minus 4, right? If we subtract, I always like to deal with the smaller one, so if we subtract 3x from both sides, right, those will cancel. That means we have 0 left. 5x minus 3x is 2x minus 4. Add 4 to both sides. Get 2x is equal to 4. Divide by 2, x is equal to 2. Okay, now y's, they're equal and congruent to each other, so we could set that up as 5y plus 1 is equal to 2y plus 4. 2y plus 4. Subtract 2y from both sides. 5y minus 2y gives you 3y plus 1 equals 4. Subtract 1 gives you 3y is equal to 4 minus 1 gives you 3. Divide by 3, y is equal to 1. Okay, classify it, identify it over here. We see that we have 4 congruent sides, definitely not 4 right angles. So this one here is a rhombus. Okay, solving for x, solving for y. If this angle here is 127, opposite angles, that means this one is also 127. Okay, and so different ways that you can find this, right? If this is 2x minus 1, you also know that this over here is 2x minus 1 because they are congruent. Opposite angles are congruent, right? So you can do one. This one's kind of going to end up kind of long, but we see that 127 plus 127 plus 2x minus 1 plus 2x minus 1 has to add up to give you 360, okay? Because all angles of a quadrilateral add up to 360. However, another way you can do this, maybe it might be a little bit shorter, right? Even though we know that those angles are represented by 2x minus 1, you can figure out what they have to equal first by just calling these x, right? Ignore this for now. We're going to come back to it, and let's call these angles just x. So this might make it a little bit easier. 127 plus 127 gives you 254. So 254 plus 2x is equal to 360, right? If we subtract 254 from 360, that gives us 2x is equal to 106. And if we divide by 2, x is equal to 53. Now, if we go back, the original angle, right, both of these angles are 53. And now we know that 2x minus 1 has to equal 53. 2x minus 1 equals 53. Add 1 to both sides, we get 2x is equal to 54 divided by 2. 54 divided by 2 gives you 27. So now the true answer of x is equal to 27, okay? Remember, this found out what both of these angles were, and then we went back to 2x minus 1 to find that equation. Okay, now to solve for y. Y is referring to side lengths, so those are congruent to each other, so we set them equal. 6y minus 5 is equal to 3y plus 7. Subtract 3y from both sides. That gives us 3y minus 5 equals 7. Add 5 to both sides. 3y is equal to 12. Divide by 3, y is equal to 4. Okay, kites and trapezoids from lesson 6.4. Find the measure of angle B. It got cut out. It's supposed to be finding angle B. All right. A quick hint. Remember, not a hint. It's something that we should remember from lesson 6.4. Consecutive angles in a trapezoid or non-base pairs are supplementary. So that means angle C plus angle B has to equal 180. So that's just 111 plus whatever B is has to equal 180, right? And we just do that real quick. 180 minus 111 gives you B is equal here to 69, right? And if we find out here, we're finding angle B again, all right? B and C have to be not congruent, supplementary, add up to 180. So 60 plus B is again add up to 180, and we subtract that and we find that B is equal to 120. Okay, find xy in each trapezoid, right? Or sorry, just for this one, find xy. We see that xy is a mid-segment. Remember, your equation for mid-segment is base 1 plus base 2 divided by 2 is equal to the mid-segment there. All right, so that means these are your bases, 2.5 plus 5 divided by 2. So 2.5 plus 5 is 7.5 divided by 2. And if we just plug that in, 7.5 divided by 2 gives us 3.75. So that means this mid-segment right here equals 3.75. In the next one here, we see we have a kite, right? Which means one of our properties of a kite is that all of these interior angles are 90 degrees, right? Which means that angle 1 is pointing at an interior angle. So we know that that's 90 degrees. So angle 1 equals 90 degrees, right? Even though actually I think this is actually angle 1, it's still 90 degrees. And then this angle here that I drew in 90 degrees is going to help us find angle 2, because then we take it and we think and we see we have a triangle here within this kite. So that means 65 plus 90 plus angle 2, let's call that x, plus x has to add up to give us 180. Remember, right? You can divide all of our quadrilaterals into triangles and use that as information as well. So 90 plus 65 gives us 155 plus x equals 180. And then if we subtract 155 from 180, we get x is equal, or x or angle 2 is equal to 25 degrees. Okay, using kites here. Again, look, notice our kite here has been cut into 2 separate triangles. Okay, this one's actually pretty challenging, all right? But what we can see is that these, remember, in a kite, one pair of angles are congruent to each other, so these are congruent to each other. So we set those equal to each other to find out what x is. 5x minus 15 is equal to 4x plus 13. All right, subtract 4x, we end up with x minus 15 is equal to 13. Add 15 to both sides. X is equal to 15 plus 13 gives you 28. All right, so that means x is 28. We can plug that in there to find out that both of those angles, if we plug that in, 4 times 28 plus 13 is 125, right? That means that, excuse me, both of these angles are 125 degrees. So if I erase this, that's 125. This one's 125. If this angle is y, that means this angle is y. And again, like I said, now we have a triangle with 3 angles. So we could set that up as 125. That's that angle. Plus this angle is y minus 9. Plus this angle, which is y. And since it's a triangle now, that has to add up to 180. Okay, so 125 minus 9. That gives us 116. Y plus y gives us 2y is equal to 180. And if 116 minus 180, that gives us 64. 2y is equal to 64. Divide by 2, and we end up y is equal to 32, right? That one was challenging. Definitely don't expect anything as challenging as that on the test. And then we take a look here, right? This is a kite. We know that that line is congruent to that line. We know that this line is congruent to this line, right? So even though these x's are not congruent to each other, they are congruent here, and x has to be equal to the same thing. So we could set this up 2 ways. 4x plus 1 is equal to 17, or 6x minus 3 is equal to 21. You should get the same answer. Let's check it out. Subtract 1 from both sides, we get 4x is equal to 16. Divide by 4, we get x is equal to 4. Add 3 to both sides, we get 6x equals 24. Divide by 6, we still get x is equal to 4. Okay, so it doesn't matter. There's 2 different ways you could solve that. You still get the same answer for x. Okay, and then at the end of the test, you will be given a shape, and you need to give the most specific name for the quadrilateral, right? Most specific, most accurate. Okay, so we see here, this is obviously a parallelogram, and we see that we have 2 right angles, which means that these also have to be right angles. We cannot conclude that we have 4 congruent sides, so the most accurate for this one is going to be a rectangle. Here we see that we have 12, 12, 14, 14, right? We have 2 pairs of congruent sides that are not opposite from each other. This one, the most accurate, is called a kite. Here, we know we have 4 congruent sides. We don't know anything about the angles, though. We know that that one's going to be called a rhombus. Okay, here we see that the diagonals are congruent to each other, right? We can't necessarily tell anything about anything else. We know this one's going to be a rectangle. Okay, here we see that the interior angles are 90 degrees. That narrows it down to either square or rhombus, but we see that all of the diagonals are not congruent to each other, so that there becomes a rhombus. Okay, here we just know that they're parallel. We don't know anything else. So the most accurate is just a general parallelogram. And once again, we see we have 4 right angles. We cannot for sure conclude if the sides are congruent. So that one would also be a rectangle. Okay, here's a bunch of links to extra credit opportunities and some extra practice. All right, just like always, how we've done extra credit in the past. Remember, you can access the slides on Canvas. You can't access these links here on YouTube. So go on to Canvas, open up the PowerPoint slides, click on these links. When you finish, take a screenshot, email it to me so that way I see that you have done it. That is how you get extra credit here for this chapter. Okay, remember, set up a study sheet, lots of properties to remember. I recommend setting up your study sheet looking like this with the quadrilateral family tree. Come to class with lots of questions. Make sure we're studying, preparing ourselves for the Chapter 6 test. Good luck, go Mustangs.